All right, since we ran out of time on that last one, just to kind of retouch on this one, if you were still kind of thinking about it, that second idea of going in and distributing because of the parentheses. This is the piece that I kind of want to look at is the idea of how did I get to here again? It's a little quicker. Like I said, those properties from the previous section are very helpful and very useful. And I know sometimes people don't like doing what I'm asking you to do, get it to logarithm divided by logarithm, because they have to get better with the properties. They would rather try and type all this stuff into your calculator. And if you think about trying to type what we have right here into your calculator, okay, a lot of people will make mistakes. I've had times where I've had my class do that and 3 or 4 people get different, or there's 3 or 4 different answers that come up. And so that's why I think it's important that we get to condense it down to make it easier when I type it into the calculator. I also think that gives you more practice again with those properties, making you get better with the idea that addition becomes multiplication and that division becomes subtraction and all this other stuff. So just to kind of take another step down here, okay, what I did again, like I said, the first thing up on the top was I need to get the 3 back into the logarithm first, because I can't do the division piece until it's logarithm minus a logarithm. Okay, and then that next step was, because it's subtraction, that's where I went to the division. Okay. Now, here's the reason why I like to deal with this distribution idea, okay, because it comes into play when I have a variable on both sides of my equation. Okay, so again, I see my variables in the exponents, the logarithm of both sides. Bring the exponent out in front. I think by now we probably are feeling pretty good about that step. And there are other ways to do this, but I think for consistency, I always like to distribute. Okay, so I'm going to have x times log of 2 plus 5 times log of 2. Over here, I'm going to distribute x times log of 3 minus 2 times log of 3. Now, again, here's the deal. You got an x in here, you got an x here. I got to get my x's on the same side. And here's where you got to do a little game planning and thinking about what's going to happen. Okay, if I bring this x over to the left side, it's going to become a negative. Change sides, change signs. If I take this piece over here, that becomes a negative. And then what I'm stuck with over here is a pair of negatives. I want to try and avoid that, okay? Because then people get confused. Do I take the negative into the exponent, which I don't want to do? But if I have both pieces negative, it's going to happen. Okay? So what I'm going to actually do is I'm going to bring this x piece to this side. Yeah, it'll make this one go from positive to negative, but at least I only have the one negative. So I got x log of 3. I'm going to start with that first. And then when I bring over the other one, it becomes minus x log 2. Okay. So I'm going to bring my non-x stuff over here to the left side. So I got the 5 log 2 over here still, but now I'm going to bring this one over here so it becomes a plus 2 log 3. Okay. Now, I still have that situation where I have multiple x's. I need to get down to a single x. So since it's common to both pieces, remember we can factor it out. Okay, and so if I take it out, I'm left to log 3 minus log 2. Okay, but now I have just a single x, which in a minute I'll get by itself. Now over here on the left side, what I'm going to do is I'm going to start condensing as I work my way down. So I'm going to bring that 5 back into the exponent. I'm going to bring that 2 back into the logarithm as an exponent, I should say. Okay. If you recognize 2 to the 5th is 32, I recommend you write that down. Okay. If you recognize 3 squared is 9, just makes it a little easier when we start getting down a little farther. Okay. So now again, what I want to do is I got x times something. So get rid of that something by dividing it out. Multiply it out to 1. So if I condense my numerator a little more, remember, addition becomes multiplication. Subtraction becomes division. Okay. But again, notice what I've gotten to. I've gotten to a logarithm divided by another logarithm which I think makes it a lot easier to type into my calculator. Okay. So log 2 to the 5th times 3 squared. Enter. Divide. Log 3 divided by 2. And I left all this together just so you can see that we will get the right answer, even if I have to type all this junk in, because it's simplified it by doing log over log. So I get 13.966. We're going to go 13.697. Okay. All right, so let's go back up. Check our answer. Very important with these big ugly problems that you do that, whether it's back of the book, okay, but when we get to a test, it's going to be good if you're able to type this stuff in and make sure it works. So 2 raised to the x, and notice again I put it in parentheses, okay, plus 5, and do the same thing with 3, x 13.967, this time minus 2, and no, they're not going to be exactly the same, okay, and because we're in the 500,000s, remember exponential functions increase very quickly. Yeah, we're off by 100, but that's pretty close because of the round off error. Okay, so hopefully, if you can go back to this example and look at it a couple times, we'll make this situation easier. And I think once you understand this type of a problem, the rest of them get to be really easy.